Hello and welcome back to Assembly Language Programming 8085. In this video, I'll show how to write assembly language program to convert binary number to ASCII. As we all know, the ASCII values of the numbers from 0 to 9 are 0 correspond. For 0, it is 30. For 1, it is 31, and so on. For 9, it is 39. Similarly, for A, it is 41, B, it is 42, and so on. For F is 46. Now we want to convert binary to ASCII because 8085 takes only hexadecimal numbers. So the binary number, we have to give it in the hexa. Now let us suppose we want to convert or 08 to its equivalent ASCII value. What is equivalent of 08? 08 corresponds to 38 ASCII value, right? Now, how to get this number? To get, so if you see here the numbers from 0 to 9, if we add 30 to each hexadecimal number, we get its ASCII equivalent. 30 plus 0, 30. 30 plus 1, 31. Similarly, 30 plus 2, 32. So 30 plus 9, 39. So to get ASCII of 08, we just need to add 30 to it. So let us convert into binary and then perform the addition. 0 equivalent is 0, 0, 0. 8 is 1, 0, 0. 30, 0, 0, 1, 1, 0, 0, 0. Add 0 plus 0, 0, 0 plus 0, 0, 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1, 0 plus 1, 1, 0, 0. So this is nothing but 3 and this is 30. So we got 38 as ASCII value of 8. Similarly, take A. So write first binary equivalent of A. 0, 8 is 10, 1, 0, 1, 0. Add 37 to it. So if you see here, if you add 37 to A and 37 to B and so on, 37 to F, we get 46. Let us check whether we get the ASCII value or not. So 3, 0, 0, 1, 1. 7, 0, 1, 1. So 0 plus 1, 1. 1 plus 1, 0. Carry. 1 plus 1, 0 with a carry 1. 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 1 plus 0 plus 0, 1, 0. This is 4. This is 40. So for A, 41. So now let us take 0B. Another example. B is 11. So 8, 4, 3, 1. That is 1, 0, 1, 1. Add 37. So 0, 0, 1, 1. 7 is 0, 1, 1, 1. 1 plus 1, 0 with a carry 1. 1 plus 1 is 1, 0. 1, 0 plus 1, 1, 1. 1 plus 1, 1, 0. 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 1 plus 0 plus 0, 1, 0. So this is 4. This is 2, 42. So ASCII value of B is 42. So to get the numbers less than A, ASCII values of the hexadecimal numbers 0 to 9, we must add 30. And from A to F, we need to add 37 to it to get their equivalent ASCII values. Because we are considering here the hexadecimal numbers instead of binary, because binary we can represent them in the hexa. Because 8085 performs operations only on hexadecimal numbers. So instead of giving the binary number directly, we are giving its hexa equivalent number, and then we are converting it into ASCII value. So always we have to give input as the hexadecimal numbers only. Now, if you for the program, just what I'll take example of for A, right? Load accumulator with 8500. So accumulator now consists of 0A. CPI 0A, because we have to perform the comparison. If you comparison is nothing but subtraction, subtract the contents of accumulator and the with 0A. That is this is 0A minus 0A. If there is carry, we have to add 30. If there is no carry, we have to add 37. I'll just tell you why we have to add, why we have to check for the carry. We can keep it in 8051. Now, so to know whether the input number is less than A or greater than A, what we do is we perform this comparison. That is, we'll subtract 0A from the contents of accumulator. Suppose if the number is less than 0A, suppose my input is 08. 08 minus 08, that is obviously 08 is greater, there will be a carry. If there is carry, what we're doing, we are adding 30. So for all the numbers less than A, we have to add 30. So when we subtract the input with from, we subtract input with the 0A, so to perform the subtraction. CPI is compare immediately the contents of accumulator with 0A. That means it performs the subtraction and sets the carry flag only. So if there is carry, that means the input number is less than 0A. If there is no carry, the input number is greater than 0A. Accordingly, we'll add 30 or 37. This is 07. Suppose here, if I take here, we'll take as 08 as the input. Now come here. So 8500, we are loading to accumulator. So accumulator now contains 08. CPI A0. So now accumulator consists of 08 minus 08. So when we subtract smaller number, right, a greater number from the smaller number, there will be a carry. If there is carry, we are looping to here, add 30, right? So they will add 30 to accumulator contents, that is 8. Then we'll get 38. That is what we are storing in the accumulator. Suppose if we take B here, 0B. Now comparison, come here. So 0B minus 0A. There is no carry. If there is carry, we have to jump here. If there is no carry, we have to go to the next instruction. So first we will add 0B with the 7. And then next it will add, next instruction is 30. It will add 0B with 07 plus 30. That means we are adding B with 37. That is what the program is. Then let's store the result in 8500. That is. So in the assembly language program, we have to do the comparison to check whether the given number is less than A or greater than A. For that, we have to perform the comparison. If it is less than A, add 30. If it is greater, if there is carry, that is the number is lesser, add 30. If there is no carry, add 37. Then we'll get its ASCII equivalent one. So that is the program. So LDA 3A, right? 0085, right? CPI 0A, FE 0A, JC DA, and loop will be to this memory location, and that address will be 0A80. ADI, add immediately C607, C630, 32, 01, 85, 76. So to convert a binary to ASCII number, we have to give input in the hexa notation only, and then we have to proceed. So for that, what we do is If the number will compare the number with the 0A. If the number is less than 0A, add 30. If the number is less than A, add 30. If the number is greater than A, 37. To know which number is lesser or greater, perform CPI and check the carry flag. For the numbers less than A, there will be carry. If there is carry, add immediately 30. If there is no carry, this condition is not being satisfied, so it has to move to the next instruction. First, it will add 7, next it will add 30, that is 37. Then store the result in 850. That is the assembly language program. I hope you all understood. Now watch the video for program uploading and execution. Thank you.